So, welcome to this session. So, in the last session we just stopped with understanding some of the limitations of firewalls and gateways. Just quickly recap, the limitations are that number 1, IP spoofing. The router actually cannot know if the data really comes from the claim source, and if multiple applications each one of them need a special treatment, like for this, for application 1 some IPs should not be there, for application 2 some other IP should not be there, right. So, they need some special treatment, each will have its own application gateway. So, you will have multiple application gateway, one each for each, and the client software must know how to contact gateway, that is must set IP address of proxy in web browser. So, even when we have a restricted access for say within a particular organization, then whenever I open a browser I need to be authenticated by the web gateway, so that all my traffic with respect to browsing goes through. So, this essentially means that you will have lot of web application proxies or gateway, and and many times the filters that we use are either you completely block or completely allow. So, it is not, there cannot be something middle, send this, do not send this. Ultimately, when we start looking at firewall and gateway, the trade off is now between the amount of communication that I want to have with the external world versus the amount of rules I am going to do here for security reasons to stop this communication. So, the trade off is between how much should I communicate. If I want to communicate more freely, if I want many people to communicate, at the same time I want security, I start putting rules. So, this trade off essentially is seen quite big by just having firewalls and gateways. So, with this as a background, in this session we will talk more about what is security in the internet. So, let us see how an attack actually happens. The attack actually happens in a very systematic fashion. So, first the attacker actually would go and find out what are the services that are implemented on your network, on your system. For that he needs to find out whether a system exists. For that he can use things like ping to determine what hosts have addresses on network. So, they can ping and find out the existence of the system, whether the system is alive or not, etc. So, that is why many times ping is disabled. If you do not, so at the point if you go and disable ping, and really when the system is not working, you cannot really go and find out whether the system is not working or there is some other failure. So, by disabling ping, nobody can basically go and find out what is happening with the system, is it alive or dead. By enabling ping, a person who need not know about the network will start knowing more about the network. So, this is basically slowly the type of trade offs. I hope all of you know what ping is. If you do not know, please go and Google it for this. Then once I know that a system exists, then I can do something called port scanning. So, for every service there is a port. So, you have only one Ethernet interface, but you have multiple ports. Every service is a port. So, what are the services that are open? So, we can actually try to establish say a TCP connection to each port in some sequence and find out which are the ports that are open. So, I will know as a hacker, by using ping I know that you exist, and then by trying to establish connections I will find out which are the ports that are open. So, many of the ports are standard ports, and you can basically go to these ports and open them. Then there is something called a Nmap mapper. Please visit this site, gives you much more about Nmap, which is actually a network exploration and security auditing type of tool. So, I strongly suggest that you have a look at this Nmap. Down the line we will give you some feedback about some more insights into this Nmap. Now, basically this is the overall modus operandi. So, someone wants to attack a system, they will try to know whether your system exists or not by using ping. Then they get a hold of an IP address, then they start doing some port scanning to find out which are all the services that are open. Then if you have a service which has a vulnerability, people then attack through that vulnerability, right. So, this is the modus operandi, and now we will see in very big view on what are the countermeasures for these type of threats, these type of what we call as an organized threat. So, there is a procedure involved to basically attack the system. The first thing is that we have to record traffic entering your network and always look for suspicious activities like some IP addresses, some port being scanned sequentially, right. So there is one fellow. So the main important thing is monitoring. Today I can't integrate security, I can't put the security here. So what I mean is that instead of putting some gate and then lot of locks inside, which you should do or you can do, one of the preliminary thing is to put a surveillance camera and see what is happening going inside. So when you want to secure your house, of course you go and put lock, gates, so many things, but more importantly a very important solution is to put a secure camera outside and always keep watching it. So that is the more foolproof way of doing it. So one of the important countermeasure you need to do is to actually record all the traffic that is entering your network, whether it is at a simple small LAN level or it is a multi major institution or multi major institution distributed geographically, or it is a nation itself. So everywhere we need to have a record of traffic that is entering a network. Once I have that record, basically even looking at the metadata basically is the header etc. information, we can do quite a bit of significant analysis, right. It is going to be big data and we can do a lot of analysis, and based on that analysis we can do some very quick things as you see in the slide. We can look for suspicious activities, like there is an IP address and that IP address is scanning all the ports one by one. Why is it doing, right? So obviously it is trying to do something with the system. So these type of analytics, real time analytics we can perform on this large data and basically understand the internet security threat. So to sum up, the internet security threat that is coming from the internet basically has a two-step procedure. First it identifies the existence of your system, it finds the IP, then it scans all your ports and find out what are the services that are open, and if there is some service that is open and then there is a vulnerability there, they try and attack it through the vulnerability. So one of the important things, the first countermeasure to stop such type of internet security violation is to go and start recording your traffic entering the network and start analyzing the traffic. It is not just it's some disk company being benefited by this, you keep storing say n terabytes of data without doing anything. Actually you have to do something with that data on a real time basis to find out something is going wrong or not. So this is the first countermeasure, and if you do this, at least 90% of the problem will get solved, but you have to do it sensibly with direction and focus. Now this is basically, in some sense it is also called as packet sniffing. What do you mean by packet sniffing? Like every packet that enters into your network you sniff and take it out. So this you can do it ethically, legally, you can basically get it out. But if you do it illegally, that is what we call it as packet sniffing. So what happens is, when I send a packet, basically it is on a broadcast media, everybody will get it, right. And so when your CPU is in promiscuous mode, or when your system is in promiscuous mode, then what happens, see, if your system is not in a promiscuous mode, right, then when I get, so let me say my IP address is P, if I get a packet which is not P, then basically the network interface card itself will throw it off, will reject it, it will not enter the system itself, right. If the destination address is not P, those packets will not come in. But if I am working in a promiscuous mode, every packet irrespective of my IP address, whether it is for me or not, will come and fall into the system. So packet sniffing is basically done by having your NIC and your CPU host in a promiscuous mode, so that all the packets, none of them will get rejected, all will be recorded. Once it is recorded, people can start looking at, by software can start looking at the IP address, source address, who is sending, all these things. This is good in one way, in the sense that if I want to capture all the incoming traffic and do analysis so that nothing wrong gets in, that is ethical, that is legal. That is also, in a sense, it is packet sniffing. But then some intruder can also do the same thing without your knowledge, and that is illegal, right. So, as you see in this diagram, C actually sniffs B's packet. So, B is actually sending something to A through the network. So, C actually sits in between and C actually sniffs the B's packet. So, this is something like a man in the middle who is trying to get all the activity that is happening between a B and A. So, how can we stop this packet sniffing? So, let us talk about an internal LAN, right, and I do not want, so there can be something internally who is sniffing all the packets and sending it out. Let us assume such a scenario. So, what we need to do is there should be a software which goes into every system and find out if the system is in promiscuous mode, if the host interface is in promiscuous mode. If it is in promiscuous mode, then that system will basically act as a sniffer, and then people can hack into that system and take back the values that are going on. So, all hosts in organization should run software that periodically check if the host interface is in promiscuous mode. If the host interface, who will make it promiscuous mode? Some third party will come into the system and make it promiscuous mode, or any internal person also can make it into promiscuous mode just for sniffing purpose. So, we should have a software that automatically every 2 to 3 hours it should keep checking whether the system has gone into a promiscuous mode. If it has gone into a promiscuous mode, immediately we need to stop and change it, because there is a potential that it can act as a packet sniffer. And whenever we are trying to broadcast, we can have something called a switched Ethernet. What is switched Ethernet? Then one person can send to all, and then when the next fellow wants, then it is again next. So, it is not that several fellows try to send to several other fellows at the same point, rather than we will have one host per segment of broadcast media. If I want to send, there will be only one fellow who will send, he will finish and then the next fellow will send. So, if multiple fellows start sending at the same time, then there can be a issue, right. We do not know who is sniffing, we do not know who is the correct one. The first one is sniffing. Of course, sniffing is done for even monitoring purposes. Sniffing is also done to basically see that there is some level of authenticity in the transactions that are happening. The second important thread that we see here is IP spoofing. What is IP spoofing? I can generate an IP address which belongs to somebody else. So, whenever I send a packet, I will generate that IP address and put it as a source. So, the destination address will think that I am not sending, somebody else is sending. So, here in case, here as you see in the figure, C is the intruder, B is communicating to A. Now, initially it was source B as you see here, but actually C is sending the packet to A. B should have sent the packet to A. Now, C is sending the packet to A when the network is free, and when C sends the packet to A, it makes the source as B, as you see here, the red color. It makes the source as B and not as C, right, because C is actually sending it, but then it is putting the source as B. So, as far as A is concerned, he will think that the message is coming from B, but the message need not necessarily come from B, it can come from something else, and that is what you call as spoofing. Here C has spoofed on behalf of B, or C has spoofed as B. So, whatever packets C is sending, it will tell A, I am not sending, B is sending, by making that source as B. So, this is basically called IP spoofing. So, how do you address this IP spoofing? Again, I do what we call as ingress filtering, ingress or outgress also. So, whatever comes in, I have to filter it. What do you mean by filtering? Many times when I want to filter things, of course, in the case of IP spoofing, I have to go filter the top to network, but in general, if I want to go and filter a packet, especially the payload as you see here, I have to decrypt that payload, go and find out if there is some signature inside that, some virus is there or not. I have to encrypt back the payload and send it back, right. So, it involves a decryption of the payload also to find out, to do ingress filtering, specifically when I am looking at application level worms that are injected through emails. So, I need to completely decrypt it, completely analyze it, and that is what I mean by ingress filtering. So, ingress filtering, if I put that filter, that means that this particular system is behaving erratically, so put a filter, nothing from that communication will reach. If that is the case, then the router should not forward outgoing packets with invalid source addresses, right. So that is what happens when we start doing the synchronous filtering and the aftermath of that. The next thing is, of course, we have been talking about, which we call as denial of service, where multiple, the SYN is a package, so multiple SYN packets are generated that go and flood the network and flood it and reach, for example, I want to do a distributed denial of service, a denial of service attack on A. So C actually sends lot of packets which actually is originated towards A, and so when B wants to access A, as you see in the figure, B is the genuine system which wants to access A. When B wants to access A, then what happens, B cannot access A because C is taken up all the resources by pumping useless packet to A, and A had to accommodate it for some time till it completely understands that C has done it, and it has to block C. Till it blocks C, this SYN package will be going to A, and B will not get access to A. So this is another very interesting important way of attack called DOS, denial of service. I am denying the service of A to the network by blocking it, by pumping it with useless packet. So again, even for this, the way is to filter out flooded packets, e.g. SYN, before reaching host, and trace back to source of floods. That is also very important. So the one is first detecting and stopping it, and the second thing, one thing is to detect and safeguard your system, safeguard your router from getting all these junk packages. The next thing is, of course, tracing back and going to the original source where that guy is originating that packet. So both are very, very important when we are trying to handle denial of service. And many times today, between any 2 points in the communication, in many of the infrastructure, IT infrastructure communication goes through something called a secure sockets layer, or SSL. So these are all the features of this SSL. So let me just go through one by one on these 5 features. The first feature is that the transport layer security to any TCP based app using SSL services. Okay. So the moment I have the secure sockets layer, I have the certification for that, then my transport layer essentially becomes secure. The second thing is, this SSL is used between web browsers, servers for e-commerce. Lot of use of SSL is there, and what SSL gives you is basically the authenticity that this is against IP spoofing. So what are the security services which SSL gives you? It gives you server authentication, it gives you data encryption, it also gives you client authentication. What do you mean by server authentication? SSL enabled browser includes public keys for trusted CAs. Browser requests server certificate and it is issued by a trusted CA, and browser uses CA's public key to extract server's public key from certificate. So all these things are basically ensures that your server is indeed authenticated by using this SSL. Now you can actually check your browser's security level by clicking on this trusted CA's website. So to sum up, SSL actually becomes a very nice platform for ensuring security, specifically on the homegrown networks. And this SSL is basically commonly used between different web servers and e-commerce, and it gives you the server authentication, it gives you data encryption, and it also gives you client authentication if needed. So there are SSL enabled browsers that include public keys, as I mentioned just earlier, and then the browser also uses CA's public key to extract server's public key from certificate. So these are some of the very interesting things that we would like to basically cover in this session. So what we have seen so far is the type of attacks that could happen, and once such type of attacks happen, what is the forensics that we need to do, and we got some very good deep insight in this lecture. We will meet in the next session. Thank you.